Okay, today we're looking at calculating angles again, so just more practice using trig to calculate angles in 90-degree triangles. So it says calculate the measure of each angle round to the nearest whole degree. So you want to compare to angle A what sides you have. So this would be the hypotenuse and this would be adjacent. So adjacent and hypotenuse is cosine, so cosine of A is 7.8 over 22. So then we go A equals cos inverse of 7.8 over 22. Get out your calculator, make sure it's in degree mode. Second cos 7.8 divided by 22. Right, you're doing the opposite of when you're calculating a side because you're pressing the second key or the shift key on some calculators. And that is, nearest whole degree is 69 degrees. Next one, compared to A, we have opposite and hypotenuse, so that's sine. So sine of A is 12.5 over 15.5. So A is sine inverse of 12.5 over 15.5. Okay, so second sine 12.5 divided by 15.5. Oops, missed the 0.5 there. Just a sec. 12.5 divided by 15.5 is 53 point, actually whole is 54. And then A here, compared to that, this is opposite and this is adjacent. Oops. Okay, so we're going to use tan. So tan of A is 20 over 27. So A equals tan inverse 20 over 27. Okay, if you have a different calculator, then ask someone for help. Okay, ask your teacher. They can walk you through it. So second tan 20 over, what did I just say that was? 27. So that rounds to 37. Okay, now when it says solve a triangle, what does that mean? It means you need to find every side and every angle. Obviously you're given some of them, but any missing angles and missing sides, you have to get all of them, not just one. So I'm going to start with this angle here. So I'm going to call it angle X, capital X. So this side is the hypotenuse and this is adjacent. So I'm going to use cosine. So cos of X equals adjacent over hypotenuse. So X equals cos inverse 16.3 over 18.6. And then, so do that. Second cos 16.3 divided by 18.6. 20 nearest tenth, so 28.8. And then I'll call this angle Y, capital Y. So then Y would be 180 minus 90 minus 28.8. So really, that's 90 minus 28.8. So 90 minus that answer is 61.2. Okay, so we found the two angles. Now for the side, you could use trig now that we know those angles, but you can also use Pythagorean theorem. So I'm going to call that little x, right? Lowercase. So x squared, it's a leg, is equal to the hypotenuse squared minus the other leg squared. So 18.6 squared minus 16.3 squared. Okay, 80.27, and then square rooting that. Okay, so 80.27, x is the root of 80.27, which is equal to 8.95. If we're rounding to the nearest tenth, then that 5 makes the 9 go up, so it's really going to be 9.0. Okay, centimeters. So that's lowercase x. So we found all of those three parts. Okay, so here's another application. When built to provide an accessible handicapped entrance, the slope of a ramp should be as small as possible. The maximum slope in new construction is 1 to 12. So that means every centimeter of rise, 1 centimeter of rise, will require 12 centimeters of run. Determine the maximum angle of inclination of the ramp shown to the nearest tenth. So basically you can see that there's a triangle drawn there. So there's the 90 degrees, and we want to find this angle here. Okay, so a slope, this means this needs to be 1 for every 12 horizontally. Okay, now it might not be 12 feet and 1 foot, it might be 12 inches and then 1 inch and then another 12, etc. But that's the ratio. So now this is the opposite side, this is the adjacent, so we're going to use tan. So tan of theta is 1 over 12, so theta equals tan inverse of 1 over 12. So second tan, 1 divided by 12, 4.8. I think that's, yep, nearest tenth is 4.8. Okay, and that's the angle of inclination. And that's it.